Hello everyone, I am Dhruv Bhatisra, pursuing Masters in Construction Engineering and Management from SEPT University. My PCM code is 25099. I will be presenting my portfolio for Studio-2, which is Construction Project Execution Monitoring and Control for the bridge project located in Ahmedabad. These presentations outline key aspects of execution planning and monitoring tools like value stream mapping, earned value management, and other used in this project, an initiative of Brownfield project at the budgeted cost of 22.72 Cr under the infrastructure sector designed to overcome the isolation between two villages during the monsoon of the Ahmedabad region. The structure includes three piers, two abutments, and retaining wall on the pile foundation. The total length of the project is 300 meters, which is consists of four main span of 20 meters plus approach roads. The total width of the bridge is 12 meter, which is inclusive of 9.5 meter carriageway and 1.3 meter walkway on the either side of the bridge for the pedestrian movement. Based on the observations like poor labor colony planning, random staking of material, inappropriate site barricading, and other findings, we have proposed this site layout, which has dedicated labor colony with attached resting area, dedicated site entrance and exit for the proper circulation, and material staking areas. Moving on to the water requirement, the preliminary source for the water at site and for the batching plant is borewell. The total water required is determined by calculating water required for labor welfare by providing 55 litre per labor per day to the peak demand. Then the water required for concrete mix was calculated by water cement ratio and other requirement calculated, which are curing, TM washing, water required for testing and for curing tanks. The total requirement comes up to the 41 lakh liter, which is inclusive of 20% wastage. Over the need of water distribution, the required infrastructure has established. The below pie chart represents the cost of establishment, where the major stake is held by procurement of borewell pumps and drinking water tumblers, and which was followed by sanitary fixtures, water tanks, and water sedimentation tanks. This slide represents the location of the batching plant, which was 4 km far from the site, and layout of batching plant, which consists of security cabin, site offices, QC lab, and cube testing area, borewell locations, and water storage areas and batching plants, with all the material staking areas and weighing bridge. And this is the parking of the site layout. For the establishment of electrical utility, the total load has been determined from all the equipments and machinery which will be used in the project at the diversity factor of 70%. UGVCL and Torrent Power are respective electrical provider for the site and batching plant. Based on the total load, load transmission line has been procured with the effective load of 65 kilowatt and 50 kilowatt respectively. The below pie chart shows electrical charges for 1 month and their cost distribution among the fixed demand charges, electrical charges, fuel surcharges, and electrical duties. For the construction planning, the total concrete for each element has calculated based on the dimensions from the structural drawings, and using the Microsoft project, the monthly requirement has been plotted. It is clearly visible that month of June has 1268, which is the peak demand. To analyze the productivity of batching plant, the peak concreting per day was determined from the MSP, and based on the efficiency of the plant, it has determined that batching plant is perfectly fit for the project. To maintain continuous pour, the transit mixture planning has been done, where the lead time calculation has done to determine the requirement of transit mixture. The total number of 5 transit mixture which are required to ensure the smooth flow of concreting. For the special condition of the contract, there were special requirements of the mold sets for this project. To determine the number of molds, the terms are thoroughly analyzed where the peak requirement of 190 cubic where we need minimum 53 molds in our inventory. As for marine and saline condition, the reinforcement planning is vital, where all the elements which are directly in contact of water, the epoxy coated bar are used, which was the lead item for this project. For the reinforcement planning, the reinforcement are calculated based on the structural drawing, which are further distributed among the element wise and dia wise. From the observation, it was determined that the handling for the reinforcement was the issue. To address this issue, the manual handling and hydra crane or mobile crane cost has been analyzed. It is clearly visible that manual handling cost weighs more than with low safety and slow speed. However, the hydra crane shows more strong presence with more capacity to handle material and it overcomes all the demerits of manual handling. Then the below pie chart shows the productivity proposal, how work can be carried out with more efficient manner to reduce the duration by eliminating 3 gangs rather than 2 for the project, which shows some strong grip on the scheduling. As other aspect of this, which is formwork planning, the total formwork requirement was determined by the area of distributed among the standard plates and some of the customized plates. However, the pier that has special formwork, which is shown in the figure, as for the inventory where we are having 2 sets of each type of formwork, therefore the repetition cycle is shown below. The based on the numbers and the weights of the panel, the cost of one set has determined, which comes up to the 13 lakh, includes of GST 18%. For the earned value management, we have observed two activity which are piling and pile cap work for the retaining wall towards south and deck slab formwork and reinforcement binding. For the tracking, we have further bifurcated these activities into sub-activities like boring, chipping, cage fabrication, and so on to keep close eye on the resources and completion of work. Based on the analysis from the Microsoft project, the output for these activities were 1.06 CPI and 0.77 SPI. Later, we have tracked for the further 2 weeks, and at the end of the third week, we have compared the data. The result was shocking due to the delay in projects. Due to overhead electrification, the project was cost burning and behind the schedule. So, this is our finding for the earned value management. By concluding this presentation, the pre-construction planning helped to understand the basic and advanced tool for consideration to how to mobilize the site and what are all the considerations should be done before establishment of any physical infrastructure. Construction planning aids to how to scatter and manage all the available resources to the time frame, where planning of peak concreting with their logistics and their mandatory terms. Reinforcement planning, which is very vital for this type of project, which are scheduled and productivity driven to develop their strategies for project. On the other hand, formwork planning plays a vital role in the comprehensive financial model to ensure the viability by reusing the formwork. For the earned value management, the softwares like MSP and Primavera supports to determine the project flow at in terms of cost and schedule, which is an essential part of management. Therefore, here I conclude my findings and understanding by the Studio 2 of Construction Engineering and Management program. Thank you.